So many of you may have been hearing in the news or on social media or from a friend or from a family member that much of the United States has been locked in a very, very big cold snap. Um, this cold snap started this past weekend over the Pacific Northwest, with the cities of Portland and Seattle experiencing record icing and snow, and their infrastructures were completely crippled. Um, that crippling infrastructure, that infrastructure crippling cold, has moved its way into the central United States. And while much of our northern states have been very, very, very adjusted to this kind of cold, places like Texas have in particular been struggling. Um, and just for example, these are two pictures. The one on the left was actually taken from my sister-in-law who lives in San Antonio, Texas. Um, and the one on the right was taken from Houston, Texas. And these are both relatively warm cities, even in the wintertime. And what I actually have here are the average highs for the month of February. In San Antonio, the average high is in the upper 60s, and the same goes for Houston. And in fact, just for perspective, I live in Northern California, and the average highs for these two cities in Texas are actually higher than my average high. And yet, if you notice, both of these cities, and in fact, much of Texas has been locked in a record cold period. And just to provide perspective, I have a sister-in-law who lives in San Antonio. I have a lot of family who live just outside of San Antonio. And so I'm very well aware of the climate of that area. And I can very, very strongly attest that this isn't normal. What they're experiencing now isn't normal. And these numbers that you see, this was actually taken from the National Weather Service earlier today. And these actually aren't even the worst numbers, but these are abnormally cold temperatures for these three regions. And so what I put up here in particular are three of the biggest cities in Texas: San Antonio, Houston, and Dallas. And all three of them were at or below freezing in the middle of the day. And this wasn't even the worst of it. Overnight last night and then Monday night, and then on Monday, they were experiencing temperatures in the single digits. And as I mentioned, like, this isn't normal. And in fact, this has been so out of the ordinary and so substantial that it's completely thrown off their infrastructure. One good example of this has had to do with power outages. So cities like Houston, cities like San Antonio, cities like Dallas or Austin are not used to this kind of cold. And as a result, when you get this kind of cold, when you get weather that is this this cold, this out of the ordinary, the demand for power goes way up. Texas in particular has a weird electricity grid that is independent from much of the rest of the country, and has a grid that is much more designed for normal conditions. Well, the temperatures have been so below normal and so out of the ordinary that that grid has been overwhelmed during these past few days. And as you can see just on this outage map, a large majority of Texas, especially in the southern and southeastern part of Texas, are experiencing large areas of blackouts, as high as 10, 20, 30% in some areas. And then other regions, other counties have even seen higher percentages. So that being said, what is causing this? And why is it something that not only doesn't disprove climate change, but actually proves it? Or maybe not proves it, but can actually be attributed to it. Well, In order for us to figure that out, we have to take a little trip. And we're going to go both up and up to the poles. So at about 30,000 feet, that's the height at which an average airliner flies. And up near the North Pole, there's a lot of cold sinking air. This cold sinking air creates an area of upper level low pressure. Upper level low pressure. And let me just really quickly demonstrate that. Just to clarify, upper level low pressure. And the reason why this happens is because there's a lot of sinking air there. The air is really cold, and so it's sinking. And so in the upper levels, you get a low pressure system. Well, upper level low pressure systems, or all low pressure systems in the Northern Hemisphere, rotate counterclockwise. And so the air that's wrapping around this low pressure system is rotating counterclockwise. And this creates the name that you've probably heard on the news or seen on social media, what we call the polar vortex. And one component of the polar vortex on the very, very southern end of it is what we know as the jet stream. The jet stream is a very important band of winds that wraps around the entire planet, and is actually both the birthplace and the freeway for storm systems. So storm systems develop on the jet stream and then travel along the jet stream. Now, that being said, what happens on a very regular basis, if I were to draw, let's say this is the equator down here. If I were to draw a half globe, like this one right here, forgive how terrible it looks, and the North Pole up here, the temperatures near the equator are always warm. They're always warm. Whereas the temperature near the pole is, whoops, sorry about that. It's cold in winter, cool, not as cold in summer. Well, meteorology 101. Regardless of any of my classes that you take, one thing I want you to know is that with the equator always being warm and the pole being colder, that creates a difference in temperature. And that difference in temperature creates a band of winds. That difference in temperature creates a band of winds. A good example of this, if you actually go to the beach on a hot afternoon, the ocean is usually not as hot, therefore the air above the ocean is not usually as hot. On the other hand, if you're inland, it can get very warm. Well, in the afternoon, you get a sea breeze that blows on shore every day, and that sea breeze is caused by those differences in temperature. Well, we see the exact same thing, but on a much larger scale in our planet. And so we have this thing called a jet stream. And the jet stream is this band of really fast moving winds that split off the warm air to the south near the equator. Let me get my little pen here. From the cold air near the pole. And this jet stream acts as the boundary between these two. Well, the jet stream, for a number of reasons, some of which are beyond the scope of any of my classes, the jet stream at times can become very wiggly. In many cases, the jet stream almost marches directly west to east. But in many cases, it ends up doing something a little bit different. Let me delete these lines and let me show you what I'm talking about. Let me actually use a different color here to really emphasize this. So sometimes what'll actually happen is the jet stream will do something like this. The jet stream will become very wiggly. The jet stream will become very wiggly. And this is the first step in explaining what Texas and the middle part of the United States has been experiencing. And here's why. So these wiggles have different names to them. This particular wiggle right here, just to give proper spatial orientation, north is up here, south is down here. This particular wiggle where the jet stream takes a sudden southerly turn, dips down to the south, and then goes back up, this is what we call a trough. Because it's shaped like a trough, kind of like a trough that an animal would feed out of. On the other hand, over here, let me use a different pen color to demonstrate this. Over here, if you notice, the jet stream makes a sudden turn back to the north, and then peaks and then goes back down to the south. This is what we call a ridge. That's what we call a ridge. Well, when we get a very wiggly jet stream, what we end up getting is a setup where cold air rides its way down these troughs, and into much further southern areas. Basically, what happens in this case is a piece of that polar vortex breaks off and stretches to the south along with these troughs. And that is exactly what's happening right now over Texas, over Oklahoma, over Louisiana. Basically, what's happening is we've got this huge trough in the jet stream just right here. And riding along that trough, the polar vortex essentially moves itself. It almost breaks off from the area over the North Pole and makes its way further south. And so now the center of some of the coldest air in the entire planet makes its way over to the northern parts of North America. Now, in particular, the polar vortex that we are experiencing now, for a number of reasons, has actually stretched much further south. We ended up having a trough that ended up extending much deeper to the south. And so the polar vortex has actually made its way all the way south to the southern parts of the United States. And so areas that normally would never get any kind of really chilly weather or very seldomly get it, have been seeing it in spades the past few days. Temperatures in places like Dallas, San Antonio, or Houston are much more common or are similar to temperatures that are much more common in cities like Chicago or Minneapolis or Fargo, North Dakota, areas that are just used to the cold. Areas that are just used to the cold. Now, that being said, a very common argument that people will make is that this phenomenon is disproof of climate change. Okay, well, it's cold outside, therefore climate change isn't happening. global warming is fake. We can burn the hell out of all of our fossil fuels. Well, not so fast. The jet stream itself depends greatly on the differences in temperatures between the equator and the poles. This map right here shows the average air temperatures. So this is average air temperatures across the entire world in the month of January. So this is actually for January. And let's just focus on the northern hemisphere really quickly. So here's the equator. And if you notice near the equator, you have temperatures in the 70s and 80s, nice and warm. As you work your way up towards the poles, the temperatures very quickly decline. You go from the 80s to the 70s, to the 60s, to the 50s, to the 40s, to the 30s, to the 20s, 10s, zeros, -10s, -20s, and so on. Well, as I mentioned earlier, differences in temperature create wind. Just like with the sea breeze, differences in temperature create wind. And on this boundary between colder temperatures to the north and warmer temperatures to the south, we have our jet stream. Now, if you take a look at the southern hemisphere really quickly. If you notice, the temperature difference from the equator to the poles is a lot smaller in the southern hemisphere. And the reason why is because that's their summertime. While the equator stays hot year round, the pole experiences a major temperature shift from winter to summer. And so the poles are much, much warmer in summer months than they are in winter months. And we can see that here in the summer months down here, in the southern hemisphere. While we're up here experiencing winter in the northern hemisphere, they're experiencing summer down there. The transition, the change in temperatures is a lot smaller than it is up here in the northern hemisphere. And if I were to actually flip and show you an image in July, you would notice that the southern hemisphere sees a bigger transition in temperatures, while the northern hemisphere doesn't. Well, it's this big difference in temperatures from the equator to the pole that creates our jet stream. During the winter time, that difference in temperature from the equator to the poles is much, much greater. As a result, the jet stream is much, much stronger. As I mentioned earlier, the jet stream is actually the birthplace of storms. What that means is that storms form and develop on the jet stream. The stronger the jet stream, the stronger those storms are, which is why wintertime storms are very, very strong. That's when we see the most intense rain. That's when we see the most blizzards. That's when weather is the most insane, with the exception of hurricanes. But hurricanes are tropical cyclones. They form via a completely different process. Now, that being said, our Earth is warming. Our Earth is warming. And a very, very, very not commonly thought thing about this is that the warming is not equitably spread across the entire globe. Some parts of our planet are getting hotter than other parts of our planet. Case in point, the North Pole in particular is actually experiencing the bulk of excess warming due to greenhouse gas emissions and due to enhanced global warming. So our North Pole is actually seeing the bulk of the warming. And this was taken from November of 2020. But I will actually say that these warm experiences, these warm spells that are happening in the North Pole are becoming much more common, way more common than they used to become. And so in essence, our North Pole is warming up more than anywhere else on Earth. And climate scientists actually expect this trend to continue. What I have here on the map right now is projected surface temperatures or projected increases in surface temperatures between 2081 and 2100. This is data taken from the Intergovernmental Panel on Climate Change. They know a thing or two about climate change. And the more orange and red and brown the color is, the more warming it is. The more yellow or tan it is, the less warming there is. If you notice, areas near the equator don't see the most warming. Areas near the equator, so that's right about here, aren't seeing the lion's share of warming. However, areas near the poles are seeing the lion's share of warming. And this is actually true both in the best case scenario, what is called the RCP 2.6 scenario. And then over here, this is the worst case scenario, the RCP 8.5 scenario. In either scenario, our North Pole is going to see the bulk of the warming. Well, as that happens, that actually causes that difference between warm temperatures at the equator to not as warm temperatures at the poles to become smaller. And what that actually does is that creates a much more wiggly jet stream. That means that the jet stream is now a lot wavier. And so we're going to get more troughs. More troughs means more opportunities for polar air to move its way south. So we're going to see a more wiggly jet stream, and therefore we're going to see more cold air intruding its way to the south, at least here in the Northern Hemisphere. The opposite is very true as well. Places that aren't experiencing that record cold are going to be seeing more warm air pushing north. And basically, we're going to see a much more dipole-like pattern where one part of the country is basking in record warmth, whereas another part of the country is locked down in record cold. But this doesn't prove, or this doesn't disprove global warming. And in fact, this may actually be evidence that global warming is happening because a warmer world is going to result in a wavier jet stream. Because that difference between warm temperatures near the equator and cold temperatures near the poles becomes smaller. And in fact, we have been seeing this more and more and more. Many of the biggest cold snaps that have happened in North America have happened in the last 10 years. And yet, even those cold snaps have not been enough to slow down global warming. Every year, global average temperatures are getting warmer and warmer and warmer. But I hope this at least explains from a 30,000 foot overview, literally because this is where it's happening at 30,000 feet, what has happened and why we've experienced this cold. Now, I'm taping this video for a lot of people, not just for a specific class. If you have questions about it, please don't hesitate to reach out to me and ask. Thank you for watching this.